Welcome! In this video, I will show you how to set up a right endpoint Riemann sum. Riemann sums calculate the area under a curve. So if I have a function, f of x, the Riemann sum would calculate the area between the function and the x-axis from a to b. Now, if I was given this function, I'd be able to calculate this area as base times height for the area of a rectangle. However, what if I was given g of x, and I wanted to know the area underneath it from a to b? I don't have a way to calculate this. This wouldn't be easy, which is why we need Riemann sums and definite integrals. By definition, the definite integral is equal to the area under the curve and is given by this notation. This is read as the integral from a to b of f of x dx. The Riemann sum will give us a way to calculate the area, but before showing you, I'd like to give you a little intuition as to where it comes from. Imagine I have this red curve f of x and I want to know the area from a to b underneath it. One way I could do this is by sectioning this interval into rectangles. Then the area would approximately be the sum of the area of each rectangle, or a sub I, the area of the ith rectangle. To calculate the area of each rectangle, I'm going to need a width for each one and a height for each one. I'm going to call delta x equal to the width. You can memorize this formula, which is b minus a divided by n, or you can think through it logically. I have an interval from a to b, and I want to divide it into n number of rectangles. So I take my length, b minus a, and divide it by n. I also want to know the height. Notice in this picture that if I plug in the right endpoint into the function, I have my height. So I'm going to call xi the right endpoint of my ith rectangle. Now notice that this formula is a plus delta x times I. Again, there's a way to reason through it. Suppose I start right here at a, and I want to know the first right endpoint. I can start at a and add delta x, the width. If I want to know the second, I could add 2 delta x, and so forth. So in general, the right endpoint is equal to a plus delta x times I, so the ith rectangle. Now if I plug this in to my function, I get the height. So we can update our area and say that it's approximately equal to the sum of our height, f of xi, times our width, delta x. Now notice what happens if I take more and more rectangles. This is 4 rectangles, this is 10 versus 20. As I take more and more, the approximation gets better and better. And in general, we want to take the limit as n approaches infinity of the sum from I equals 1 to n of f of xi times delta x. This is the area under the curve and is equal to the definite integral. Let's do an example. The problem states, find the right endpoint definition of the following definite integral. The integral from 2 to 5 of 2x cubed dx. Remember, f of x, in this case, is 2x cubed. I recommend drawing a picture like this one on all of these problems. To set up the right endpoint Riemann sum, we need a width for each rectangle, and we need a height. The width is going to be delta x, and remember, we're going to take the length of our interval, which is b minus a, and divide it by the number of rectangles n. In this case, we have that b is equal to 5 and a is equal to 2. So we get that the width of each rectangle is 5 minus 2 divided by n, which is equal to 3 divided by n. For our height, we need our right endpoint, xi. Remember that we can start at our starting point, a, and then we need to add however many widths we need to get to our certain rectangle. So we need delta x times I. A is 2, and delta x we just calculated right here is 3 divided by n. So we get that our right endpoint is 2 plus 3 divided by n times I. Now we can begin to set up the right endpoint Riemann sum and say that the definite integral is equal to the limit as n approaches infinity of the sum from I equals 1 to n of f of xi. F of 2 plus 3 divided by n times I times delta x, which is 3 divided by n. Well, we know the function is 2x cubed. So we can write that this is equal to the limit as n approaches infinity of the sum from I equals 1 to n of f of 2 plus 3 divided by n times I. Plug this into our function. 2 times 2 plus 3 divided by n times I cubed. And then we need to multiply by our delta x. And this would be the answer for a problem like this. Check out these resources as well as the Aggie Math Learning Center for more information and for more practice problems.